This question is asked in gate 22 of electrical. This is from signal system subjects and related to LTE system. The question is, let a causal LTE system be governed by the following differential equation, where xt and yt are input and output respectively, its impulse response is. So one of the simple method to solve this problem is by going to the Laplace approach. So what I'll be doing is, I'll be taking Laplace of this given differential equation both sides, and then we'll see. So basically, what is impulse response? One of the way to define the impulse response is the inverse Laplace transform of the transfer function represent the impulse response, right? So what is transfer functions? The output by inputs in the Laplace domain is the transfer function. So first we'll be finding y of s by x of s, that is what your h of s, and then if you take its inverse Laplace, that will be your impulse response. That is what is the plan to solve this problem. So if I apply Laplace transform both sides of this equation, y of t Laplace is y of s plus 1 by 4 dy by dt, its Laplace transform is s into y of s is equals to 2 into x of s. So if I take y of s as common, this happens to be 1 plus s by 4. This is equals to 2 into x of s. So your y of s by x of s is basically 2 divided by 1 plus s by 4. Okay, so this is what your h of s is. And if I multiply 4 both sides, in numerator and denominator, this happens to be 8 divided by s plus 4. So this is what your h of s. So if you do h of s, then its impulse response, that is h of t, is equals to 8 into e raised to power minus of 4t into ut. So this is what is impulse, 8 into e raised to power minus 4t ut, which is given in option D. So D is the right answer for this question, which is very simple and straightforward questions. Just we have to take Laplace both sides, that to be a very simple first order differential equations with zero initial conditions. Then by taking the y of s by x of s ratio and by finding the inverse Laplace, the answer is coming 8 into e raised to power minus 4t ut. So option D is the right answer. This question is asked in gate 22 of electrical. This is from signal system subjects and related to Fourier transform topic, you can say. The question is, let an input x of t equals to 2 sin 10 pi t plus 5 cos 15 pi t plus 7 sin 42 pi t plus 4 cos 45 pi t is passed through an LTE system having the impulse response h of t is given, right? The output of the system is. Okay. So such kind of questions, when you see like there is some input, so which is the combinations of sinusoids of different frequency, and it is being passed through a system. So most of the cases when you find this kind of framing, generally this impulse response, this represents a filter. So basically there is a input signal which is combination of different harmonic sinusoids. It is passed through a filter. What is the output of the filters in simple language? But what kind of filter this is, that is what is indirectly given to this impulse response. We have to use our skill to know what kind of system or filter this represents. So the first target is to get the Fourier transform of this. Only when you know the frequency response property of this filter of the system, then you may proceed. So for this, I'll be using some standard results, which are very, very standard results in the theory. I believe all of you have studied this. That is, if you have a system which is time domain expression is k into sine at divided by pi t. Okay, if this is what the time domain functions, this represents a low pass filter. Okay, this is the frequency axis. Okay, and this is the cutoff frequency. I mean, these points are minus a, and this height is k. So whenever you have k sine at by pi t, so this always represents a low pass filter. Why I am using this? Because here I have something which is like this, k into sine at by pi t. And I have one more property to tell you here. So in other words, okay, so if I use this property for this function, so if I say 2 sine of 10 pi t divided by pi t, if this is what is my time domain function, its corresponding frequency response characteristic will be something like this. This is a low pass filter. These points are minus 10 pi and this is plus 10 pi, and this height is 2 because this factor is 2 here. Okay, so let's say this, okay, this is what we know now. Okay, so one more property I would like to discuss here, that is, if we have x of t into cos of omega naught t, Okay, so instead of x of t, so let me use gt because x of t is already given in the question. So if I have gt into cos of omega naught t, its Fourier transform happens to be half of g of omega minus omega naught plus g of omega plus omega naught. Okay, now, so in this particular questions, h of t is given this one. So let's say this is equals to g of t into cos of 40 pi t. So what is g of t? So this bracket term, that is 2 into sine 10 pi t by pi t. This is what I mean by gt in this case. So basically this is your gt and this is your g of omega. Okay, so now, so I already know what is g of omega. So this is my g of omega, right? So this is my g of omega. So this is my g of t and this is its Fourier transform g of omega. So the given function, which is your h of t, okay, so h of t is nothing but gt into cos of omega naught t. So h of t I have expressed in terms of gt, so I can easily get its corresponding Fourier transform, that is h of omega, using this property. Okay, so your this is what your h of t is, right? So h of t is equals to g of t into cos omega naught t. So what is your h of omega? H of omega, this is what h of omega. So if this is h of t, then this is what your h of omega. So let us try to plot this h of omega. So for that, so what I'm doing is, so now you try to plot this g of omega minus omega naught. By the way, what is this omega naught here? So this is, cos omega naught. If you compare, this is what is omega naught. So omega naught is 40 pi, right? So this is g omega minus, so here this is 40 pi and here you can substitute here plus 40 pi. So g of omega is this function, okay? This is centered at 0. So this is what g of omega. So if you shift this 40 pi towards right, because omega minus 40 pi, if you delay in the frequency axis, so what are the points? So this point will come, 40 minus 10 pi is 30 pi and 40 plus 10 pi is 50 pi. And the center frequency, which is 0, 0 plus 40 pi is 40 pi. In the same way, so if this is what is the factors because of g of omega minus omega naught, for g of omega plus omega naught, you will again get a rectangle with the negative axis, with the negative real axis. So this point will be your minus 50 pi, this point will be a minus 40 pi, and this point will be your minus of 30 pi. But what is the height of this rectangle is what I'm saying. So here if you see, this g of omega, this height is 2, okay? And here I have this additional half multiplying factors because I am plotting for h of omega, right? So this is what I plotted, is only this this bracket term I have plotted. So excluding this half. So if I am saying this is what is my this bracket term, that means my height is 2 and 2 here. But because of this half, so when you multiply this, 2 into half become 1. So this is your 1 and this is your 1. So this is your h of omega now. So this is your h of omega. So basically what is being given is the impulse response h of t is given. So from this we have obtained its corresponding frequency domain behavior, which is looking like this, and this is nothing but a band pass filter, right? So band pass filter, and that to be its cutoff frequency are 30 pi to 50 pi. So it is very simple now. So indirectly they are telling you, like we have a band pass filter having passband range from 30 pi to 50 pi. To this particular system, if the input is this one, so what is the output? So now you have to see in this frequency range, in 30 pi to 50 pi, which of the sinusoids of inputs are coming, which are not coming. Those are coming, they will be passed. Those are not coming, they will be blocked. So now let me check one by one. So what about this first one, this 2 sine 10 pi t? Will it be produce the output? It's not. So basically the situation is something like this. So this is the filter, which h of omega is the characteristics, and to this the input is x of t. So now we are trying to find this y of t. So this x of t expression is given in the questions, right? This is what is the x of t expression, and this is what is the frequency response h of omega. So now I am checking what will be getting at this output yt. Okay, so for the first sinusoid is 10 pi. So where this 10 pi is, 10 pi will be coming somewhere here. So this point is your 10 pi. So 10 pi is not coming, so this will be blocked. So this will not be produced at the output. What about 15 pi? 15 pi also same story, because 15 pi will be somewhere here. So it will also be blocked. What about 42 pi? 42 pi will be coming somewhere here. So is it in the passband? Yes. So this will be passed. And 45 pi. So yes, this is also coming in the passband somewhere here. So this will also be passed. So this inputs, okay, if it is passing through the systems, the first two sinusoid will be blocked because they are coming in the stop band range, and these two will be passed to the outputs because they are in the pass band range, and the filter gain is 1. So as it is, the inputs will be passed, I mean these two segments. So 7 sine, so yt, if I ask you, so it will be 7 sine 42 pi t plus 4 cos 45 pi t. So this will be your outputs. That's all. And if you check, this is given in option C, 7 sine 42 pi t plus 4 cos 45 pi t. So this is the answer. So key is option C for this. So these questions may look complicated to some of you, but it is very simple and standard result based questions, right? If some of you know this particular results, like if this is what is your this standard low pass filter property and this GT cos omega naught property, if you know these two things in your mind also, you can easily figure it out. This is how h of omega will look like, and based on this frequency cutoff points, you can decide what will be produced in the outputs. So answer is option C for this. This question is asked in gate 22 of electrical. This is from signal system subjects and from DTFS topic. The question is, the discrete time Fourier series representation of a signal x of n with period n is written as this expression. A discrete time periodic signal with period n equals to 3 has the non-zero Fourier series coefficient a of minus 3 equals to 2 and a of 4 equals to 1. This signal is actually such kind of questions we used to solve. In past also it has been asked in the CTFS topic multiple times. Like a spectrum information will be given. Based on the spectrum information, you have to obtain the time domain signal. The same question has been framed, but in the DTFS case. So the spectrum informations of the DTFS is given. We need to get the x of n expressions. The speciality of the DTFS and the DFT, the speciality is in the time domain and frequency domain, both signals are periodic with the same period. In other words, if I am saying that x of n is the signal and its DTFS is a of k, if I am saying this signal x of n is periodic with 3, that means this a of k is also periodic with 3 samples. It happens in case of DTFS and it also happens in case of DFT. Both domain signals are periodic with the same period. Okay. So if the signal is periodic, okay, what you can with the same period, I can say here x of n plus or minus n naught. Okay. So this will be same as x of n. Similarly, a of k plus or minus n naught will be same as a of k, where n naught is the period of the signal, which is 3 here given. Okay, fundamental period 3. So here I can say here a of k is equals to a of k minus 3. You can say plus sign also, no problem. Okay, a k of plus or minus 3. You can say like this. So we need this information while solving these questions. And you see clearly here it is given that the non-zero Fourier series coefficients are this one. I mean, there are only 2 non-zero coefficients. Remaining all coefficients are 0. So now let us do one thing. Let us try to expand this expression x of n, which is this one. So here if you see x of n is given as summation k from 0 to n minus 1. So n value is 3. So 3 minus 1 is 2. Into this is a of k. This is e raised to power j 2 n pi k divided by capital N value is 3. So now let us expand this by substituting different value of k. So if I substitute k equal to 0, you get a0, and this exponential factor e raised to power 0 is 1. If I take k equals to 1, what do you get? You get a of 1 into e raised to power j of, if you substitute k equals to 1, this is 2 pi by 3 n plus if you substitute here what k equals to 2, you get here a2 e raised to power j of 4 pi by 3 into n. Okay, this is what you will get. So now the point is, so here if you see, to get this x of n, I need this a0 value, I need a1 value, I need a2 value. But these all value are not given in the questions. Rather, a of minus 3 value and a of 4 value is given. So does it mean that everything will be 0 and 0 will be the answer? Of course, it's not that way. And 0 is in fact not in the options also. So that's why you need this property here. Okay. So what I need a of 1 I need, and I need a of 0, and I need a of 2. Okay, so in these equations, so because I need a of 0, so let me first substitute k equal to 0. So a of 0 is equals to a of 0 plus or minus 3. So what does it mean? A naught is equals to a of minus 3, or a naught is equals to a of plus 3. So here a of minus 3 is given. So a naught is equals to a of minus 3. So one thing is confirmed, that a naught value is basically a of minus 3, which is 2. So I need a naught is 2. Similarly, let us try to get a of 1 and a of 2. So in this equation, again, let me substitute k equals to 1. So a of 1 is equals to a of 1 plus or minus 3. So that means what? A of 1 is equals to, if I take plus sign, I'll get a of 4, or if I take minus sign, a1 is equals to a of minus 2. But in the questions, if you see, a4 is given, right? A4 is given. So a4 value we know, so which is given how much? 1. So that means what? A1 is equals to 1. That means A1 is equals to 1. So now let me substitute here 1. This is e raised to power j of 2 pi by 3 n. Now what else you need? You need a2. So you have to substitute k equals to 2. If you substitute k equals to 2, what do you get? A of 2 is equals to a of 2 plus or minus 3. That means a2 is equals to a5, or you can say your a2 is equals to a2 is equals to, if you take minus sign, 2 minus 3 a of minus 1. Now a5 and a minus 1. So what are these values? These values are 0, because if you see, the non-zero coefficients are only this much. That means remaining all coefficients are 0. So that means what? Because a5, a minus 1, these are 0. So I can say here your a2 is equals to 0. So in these equations, we need a0, a1, a2 values. So a0 we got 2, a1 we got 1, and a2 we got 0. So if a2 is 0, so this term is completely gone, it is 0. So we have only, this is what is the expressions. 2 into e raised to power j 2 pi by 3n. But if you see, no option is matching with this. In fact, some mathematical manipulation is necessary, so to bring in these formats. And you know very well, because in all the options you are getting these cost factors. So it is a clue to you, like you need the form of e raised to power j omega n plus e raised to power minus j omega n by 2. That model, if you do some manipulations, you will get these cost factors. So that's why what I'm doing is, so in this case, so let me take a factor common, that is e raised to power j 2 pi by 6n, e raised to power j 2 pi by 6n. One of the ways you can expand these options and you can check which is matching with this one, but that will be lengthy. Otherwise, then what I'll be doing is, then I'll check, okay, to get these cost factors. So in all the options, I have this e raised to power j 2 pi by 6n common. In one options, in two options, right? In two options, this is common, and one case e raised to power minus j 2 pi by 6 is common, e raised to power j 2 by 3 common. So you can try with this one. So first, let me take it is e raised to power j 2 pi by 6, because if you think mathematically, it seems if I take this factor common, our answer will match. I mean, if I take this way, so this will match. Otherwise, you have to go one by one. Okay, so let me take this factor common. If I take this factor common, this will be e raised to power j 2 pi by 6n plus e raised to power minus of j 2 pi by 6n. So that if I multiply this and this, I'll be getting these factors, right? So e raised to power 4 pi by 6, which is 2 pi 3n, and if you multiply this one, this will be this. Okay, so here if you see here, okay, so one more small mistake I did. So this is basically 1 plus this one, you can say. Why? Because this and this, if you multiply, okay, so you'll get this is e raised to power j 4 pi by 6 n. 4 pi by 6 is j 2 pi by 3 n. Okay, and if you multiply this and this, it is e raised to power 0 is 1. So that's why this is 1 and this is 1. 1 is equals to 2. So these two expressions are equivalent now. So this is equivalent to 1 plus e raised to power j 2 pi by 6n. Okay. And now let me multiply 2 and divide 2. So 2 into e raised to power j 2 pi by 6n plus e raised to power minus j 2 pi by 6n divided by 2. So that these two and these two will be cancelled out equivalently. These expressions and these expressions will be equivalent. So this is equivalent to 1 plus e raised to power j 2 pi by 6n, and okay, so because of these two factors, so I am writing here 2, and this square bracket term, this is nothing but your cos of 2 pi by 6n. So this is what is your x of n is. So 1 plus so 1 plus 2 into e raised to power j 2 pi by 6n. Okay, if you see this one, so this is matching with which one? Option D is not correct, because in the D we have this factor is coming, okay, but this is 2, we need 1, so this is D is wrong, and these factors we don't have in common, so this is also wrong, and this is negative sign, this is also wrong, so this is the correct answer. If you check 1 plus 2 into e raised to power j 2 pi by 6n into cos 2 pi by 6n, that's what we are getting. Okay, so this is again a not tough problem, but yes, so once somebody reaching into this conclusion, so reaching into the correct options, it needs some mathematical calculations, so you should be careful about it. Otherwise, if you check each options by expanding the cos in terms of e raised to power j omega plus minus j omega by 2, you can also match it. So it is given in option B, so hardly it will take 1 minute to reach from this first two options to these expressions. So okay, so this is a good questions. So we have the DTFS questions, so where we use the concept that in both domain the period of the signals are same. Using that one, we extracted the value of A1, A0 and A2, and by substituting and by simplifying, we got the answer which is coming as B. So B is the right answer. This question is asked in gate 22 of electrical. This is from signal system subjects and from system property topic. The question is, consider the system as shown below, where yt equals to x of e raised to power t. Then the system is, so if you see the options, so they're asking regarding the linearity and causality, right? So whether the system is linear, non-linear, or it is causal or non-causal. So how do you solve the problem? So regarding the linearity, if you see, if you observe this expression carefully, no manipulation is done with respect to amplitudes. So the manipulation is done with respect to time. So there is no questions of it is non-linear, right? Because if we are only manipulating the time, nothing in the amplitude sides, so why there it will be non-linear? There is no chance at all. So the system is linear. So this is a linear system. Otherwise, you can go by testing the homogeneity and additivity. Okay, we'll do that also. And what about causality? Causality means we have to test the outputs by substituting different value of time, so that like if we get some situations like present input is depending on the future informations, present output is depending on the future inputs, then we can say it is non-causal. So in this equation, so if I substitute here t equal to 0, so y of 0 is x of e raised to power 0. E raised to power 0 is 1, so y of 0 is x of 1. So what is the meaning of this equations? To get the output at t equal to 0, you need the input at t equals to 1. So to get the output at t equal to 0, you need the input at t equals to 1. That means with respect to 0, 1 is future or not? Yes. So here we have the future dependency. If you get there is future dependency, it means this is a non-causal system. Very simple. So this is non-causal system. So option A is wrong and option C is wrong. And non-causal and linear, if you see, this is option B. D also wrong. So if you want to check the additivity, so what is the meaning then? x1t, it is producing x1 of e raised to power t. x2t will produce x2 of e raised to power t. Right? So to be very specific, if I say it is ax1, you will get A. If I say B, you will get B. So now, if I give together this one, ax1t plus or minus B of x2t, so what do you get? So if you see, the system is, what it is making, it is just changing the t to e raised to power t. So what is the change? So wherever t is there, it will be making it e raised to power t. So it is A of x1 of e raised to power t plus B of x2 of e raised to power t. Now don't you think this is nothing but the sum of this and this? Yes, this expression is sum of this and this. That is what is the additivity. So yes, it is linear as well. So the system is linear non-causal. Option B is the right answer. It's very straightforward. By looking the question itself, you can tell the answer. No need to do even this much of analysis. So answer is option B.